Okay, hello everyone. Today we are going to look at basic algebra and algebraic manipulation, and this is from secondary 1 mathematics. So what are the learning objectives for this topic? The first objective will be to use letters to represent numbers and variables. Second, interpret algebraic notations such as AB equal to A multiplied by B, A squared is equals to A times A out of B is equals to A divided by B. Third, express basic arithmetic processes algebraically. Fourth, evaluate algebraic expressions. Fifth, add and subtract linear expressions. Sixth, simplify linear expressions which may involve brackets or fractional coefficients. Next, factorize algebraic expressions by extracting common factors. And lastly, translate simple real-world situations into algebraic expressions. So first, what are the notation and terminology in algebra? So in algebra, letters, for example x, y, a, b, z squared, etc., are used to represent numbers and unknown values called variables. So mathematical statements like x plus 3y, 3a out of 2b, x squared plus 2x minus 3 are known as algebraic expressions. So an algebraic expressions involves numbers, variables, and operational signs, such as the four basic operations plus, minus, multiply, and divide. So the plus and minus signs in an algebraic expression separate it into terms and are used similarly in arithmetic. So for example, a plus b equal to c. It means that the sum of two numbers which are represented by a and b is equal to the number represented by c. So these numbers are unknown. That's why we represent them using alphabets. So 2x minus y equal to z. And this means the difference of two numbers which are represented by 2x and y is equal to the number represented by z. So representation of mathematical relationship using algebra. So mathematical relationships in the form of word statements can be translated into algebraic expressions as shown in the table below. So there are four examples and there are four word statements. So you got to change these word statements into their corresponding algebraic expressions. So example 1, add 5x to 2y. So what will be the algebraic expression? What about subtract 2x from x squared? Third example will be product of three consecutive numbers with the smallest number being represented by n. And last, example 4 will be cube of variable a divided by the product of 3b and c. So can you try first? You may pause the video in the meantime and then proceed once you have completed. Okay, so the algebraic expression for example 1 will be 5x plus 2y. For the second example will be x squared minus 2x. For the third example, this could be tricky, but it's actually n bracket n plus 1 bracket n plus 2. So when you talk about consecutive numbers, you have to add 1 to the previous number. So let's say the number is n, so the next number will be n plus 1. Then the number after that will be using n as a base, say n plus 2, because n plus 1 plus 1. So the last example, example 4, will be a cube divided by 3bc, a cube out of 3bc. Okay, so an algebraic expression is made up of different parts. So consider the expression 2x squared plus 2x minus 3y plus 4 and refer to the table below. So the terminologies are variable, coefficient, term, constant, degree, and polynomial. So these are the terminologies used in mathematical relationship or algebraic expression. So what is the Definition of variable is a letter that represents a number. So for example, it's x and y. They are called variables. So what are coefficients? Coefficients are the number that is multiplied to the variable. So for example, for 2x, the coefficient of x is 2. For negative 3y, the coefficient of y will be negative 3. So you got to include the sign in front of the number. So negative 3. So term can be a number, variable, or the product of a number of numbers and variables. So for example, x square, the expression x square plus 2x minus 3y plus 4. So there are actually four terms. So these four terms are x square, 2x, negative 3y, and 4. So what is a constant? Constant is a term with a fixed numerical value. So 4 is a constant. So what about degree? So the degree of an expression is the highest index observed in the terms of the expression. So what is the highest index for the above expression? X squared plus 2x minus 3y plus 4. So the highest index is 2. Why? Because it's from x squared. So polynomial is just the algebraic expression consisting of one or more terms. So the polynomial is the algebraic expression x squared plus 2x minus 3y plus 4, because there are four terms in this expression. So it's just for you to know the terminologies. So write down an algebraic expression for each of the following statements. So for these 5 examples, you got to write the mathematical relationships algebraically. So subtract twice the variable p from the product of 6p and q. Okay, this will be 6pq minus 2p. What about multiply the square of r by 6q? So it will be 6qr square. What about if a class has x boys and the number of girls is thrice that of the number of boys? Find the total number of students in the class. So the expression will be 4x, because there are x number of boys, and since number of girls is thrice, so of that of the number of boys will be, number of girls will be 3x. So 3x plus x will be 4x. So if 5p pencil costs x dollars, find the cost of 2 pencils. So 5p is equals to x dollars, so p will be x out of 5. So we multiply by 2 will be 2x out of 5p. So yeah, so 1 pencil will be x out of 5p. So 2 pencil will be 2x out of 5p. So if an apple costs x plus 10 cents and an orange costs 2y cents, find the cost of A apples and B oranges. So because one apple is x plus 10 cents, so A apples will be A bracket x plus 10 close bracket, and B oranges will be 2by. So you add them together. You don't have to expand the A bracket x plus 10. Okay, just leave it as such. Okay, evaluation of algebraic expressions. So given that x equals to 2, y is equal to negative 1, and z is equal to 5, evaluate each of the following expressions. So there are 3 examples here. Basically, you got to substitute those letters x, y, and z with their following numbers. Okay, so for x it will be equal to 2, y is equal to negative 1, and z equals to 5, and then you calculate it. So take some time to try it first, then I'll give you the answer now. So A will be, the answer will be 9, B will be 4, and C will be negative 27. Right, next. What about addition and subtraction of linear expressions? So there are three examples here. Find the sum of 5h minus 2k plus p, 4k minus 3h minus p, and 7p minus 2k plus h. So you got to add the three algebraic expressions together to find one expression only. So part B, you got to simplify the following expression. So part 1 will be 3 bracket m minus 3p close bracket negative minus 5 open bracket 2p plus 5m close bracket. And for part 2, 7a minus 2 bracket 3 bracket 5a minus b close bracket minus 2 bracket 4a minus b close bracket. So try it first. So part A, this is what you get. Okay, so you open the bracket because it is just sum. So when you open the bracket, you just open it like that. Okay, and then you group the similar variables together. So h together, k together, and p together. And then you'll find that when you simplify it, you subtract and plus together, you get 3h plus 5p. Okay, next. Okay, simplify the two expressions. So when you open bracket, 3m minus 9p. So for this case, because there's a negative sign in front of 5, so you gotta take negative 5 multiplied by 2p is equal to negative 10p. And then negative 5 multiplied by 5m will be negative 25m. So the negative sign take precedence over plus. So 3m minus 25m, put all the same variables together, and negative 9 minus 10p. So it's negative 22m minus 19p. Okay, what about the next one? 7a minus, so you open the bracket, the one inside first, so negative 2, 15a minus 3b minus 8a. So negative 2 multiplied by negative b, you get plus 2b. Okay, then after that, you open the bracket. So negative 2 multiplied by 15a, negative 30a. Or wait, so you simplify this first. Alright, 7a minus b. 15a minus 8a equal to 7a. Negative 3b plus 2b is equal to negative b. And then you open the bracket, it's easier. Okay, so negative 14a plus 2b. And you get negative 7a plus 2b. Okay, next. Multiplication and division of algebraic expressions. So simplify the following. So I'm not going to say it out. So you look at this. So remember, if you have common, you can, if when you divide two algebraic expression, you can cancel the same variables. Okay, so let's see. So for part A, when you multiply these two expression first, so 10p cube, q cube, and r out of 4p r square. So if you simplify 10 and 4, you get 5 out of 2, and then p you cancel, you get p square. Q, there's no common variables below, so it's q cube, r you can cancel, so you get out of r. So this is the answer, 5p square q cube out of 2r. Okay, next. Alright, so first you open the bracket for this, so you get y square z square, and then you can simplify the y, the x, and the z. Z you can cross simplify, which we have learned in P5, cross simplification. And then the numbers you can simplify them. You will get 14x 5 out of 5 power 5 z. Okay, just need to be careful. Do one at a time so that you don't, and check again so that you don't make careless mistake. Alright, simplification of linear algebra, algebraic expressions with fractional coefficients. So express the following as fractions with a single denominator. So we have 2x minus 3 out of 5 plus x minus 3 out of 3. And 2x plus 5 out of 2 minus 6x minus 3 out of 5. And 1/3 bracket 2x minus 7 close bracket minus 1/9 bracket x minus 6 close bracket. So for this case, just like fractions, you got to make the denominator the same. Then you can combine the two fractional algebraic expressions together. So just imagine these are fractions. So like what I've learned in primary school, when you add fractions or subtract fractions, you got to make the denominator the same. So just do one at a time. So for part A, we make the denominator the same. You multiply by 3 for this fractional algebraic expression. This one multiply by 5, so it'll be out of 15. And then you just do the numerator, simplify the numerator, and you will get 11x minus 24 out of 15. Right? Okay, next part B. So now is minus, but it's still the same. Make the denominator the same by multiplying by 5 for this expression, and for this expression it will be multiplied by 2. So that the base, the denominator will be 10. And then you simplify the numerator. Remember negative 2, you got to multiply by 6x will be negative 12x, and negative 2 multiplied by negative 3 will be plus 6. That's the important thing you got to take note of when you are expanding your algebraic expression. So when you're simplifying, just put the similar variables together, and check again, make sure you don't make any unnecessary careless mistake, and you get negative 2x plus 31 out of 10. So you can't simplify anymore, so you just leave it as such. Okay, part C. So same thing, make the denominator of the fraction the same by multiplying 3 numerator and denominator to 1/3. You get 3 out of 9. This will be the equivalent fraction. 3 out of 9 is equivalent fraction of 1/3. So then you can combine the two expressions together. So but remember, this is negative 1 multiplied by x will be negative x. Negative 1 multiplied by minus 6 will be plus 6. So just take note of the negative sign. Don't miss out. When you simplify it, you get 5x minus 15 out of 9. This is the simplest form. You can't simplify it anymore. So just leave it as such. Okay, factorization. Factorize each of the following expressions completely. So factorization is just means the opposite of expansion. Just put it together as compact as possible. Okay, and you need to include some brackets whenever possible. So for example, 3x minus 12, you can see that 3, you can take out 3 from 3x, then you'll be left with x. Take out 3 from 12, it will be 4. So you get 3 bracket x minus 4 close bracket. So for part B, 4bc minus 20ab. So what is common for 4bc and negative 20ab? So you can take out 4. This is common. Take out 4. This will be left 20. You are left with 5. B, you can take out b. C, you can't. So 4b minus bracket c minus 5a close bracket. So for this, you can see you can take out 3. You can take out m. So 3m bracket x minus 4a plus 5 close bracket. The last one, what common for the terms, the 3 terms here? Okay, 2, take out 2, you can take out x. That's all. Y is only only here in this term. Yeah, and that's all. There's no c for this term also, so you cannot take out c. So 2x bracket c plus 4y minus c 9cx close bracket. Okay, last one. Translate real life situations into algebraic expressions. So there are many types of word problems, and these word problems will be related to real life context or real life situations. So it's just one example. So in a burger eating contest, the champion ate double the number of burgers as the second runner-up, and 12 more burgers than the first runner-up. So first runner-up means the second place, second runner-up means the third place. Find the total number of burgers eaten by all three winners. First, second, third, interval x, where x represents the number of burgers eaten by the champion. So the champion had eaten x number of burgers. So because the champion ate x burgers, the second runner-up and the champion ate double the number of burgers as the second runner-up. So number of burgers eaten by the second runner-up will be half of x. So half x. So and the champion ate 12 more burgers than the first runner-up. So number of burgers eaten by the first runner-up will be x minus 12. So we have x for the number of burgers for champion, half x number of burgers for second runner-up, and x minus 12 number of burgers for first runner-up. So you got to add them together because we will find the total number of burgers eaten by all three winners. So half x plus x minus 12 plus x, 3. And when you add them together, half x plus x is actually 1 out of 1. Or you can say it's 2 out of 2. So half plus x plus x will be 5 out of 2x. And then negative 12, just negative 12. Okay, so you just one example. So we'll do more practice next time in the next video. So these are all the learning objectives. I've covered all the learning objectives for this topic. And if you want to know if you have mastered the topic on basic algebra and algebraic manipulation, you have to know all the learning objectives covered in this topic. So if you know how to use letters to represent numbers and variables, interpret algebraic notations, express basic arithmetic processes algebraically, evaluate those expressions, add and subtract linear expressions, simplify them, whether they involve brackets or fractional coefficients, factorize them, and do complete solve the word problems related to real world situations involving these algebraic expressions. So then you have mastered the concept taught in this topic. Okay, thank you. Do your best. More practice be given in the next video. Right. Thank you.